This is a water sample taken from a property in New York City that is currently being treated by a water treatment company. This system is a 150 psi system. This is a dual temp system. Steam boiler feeds to a heat exchanger. Heat exchanger on the other side has a dual temp system that for 5 months operates in the heating mode, and for 5 months those valves are closed, and then it operates through a plate and frame and becomes the cooling mode. This system, you can see, is heavily fouled in iron particulate, suspended.
That's a clear bottle?
Yes. The current system is actually being treated with a biocide, and it looked like almost a quat rather than a non-oxidizer, which is really what should be used, like a glutaraldehyde or a isothiazoline. I know that because the system had been also mixed with glycol at one time, and it was also being treated with nitrite, which can also be used as a food source. Okay, at this time I'm going to take this water sample and I'm going to just show you how heavily it is fouled with particulate. I'm actually putting a flashlight to the bottle and you actually cannot even see it out the other side. That's how much debris is in this. What I'm going to do is basically simulate to see if filtration would also help as far as a treatment, to help the treatment actually work better than it is currently working or being applied. This is a 0.45 micron filter. What I'm going to do is I'm going to take a sample. I'm going to just take one sample of the dirty water to simulate the potential to change this through filtration. How much we can actually get out of this, the iron and other particulate that's in here. I actually had already ran an iron test on this system, and it's actually, I have to dilute it so many times to get it to even read through my spectrophotometer. Alright, this is just through ordinary filtration. You can see how drastic that is. The reason why you actually have that much particulate in it is because of improper treatment. One of the things is definitely due to glycol contamination and not treating the system properly with the right biocide at the right feed rate, and also the right levels of corrosion inhibitor. One of the things that I'd also like to do is, after we just we took a look at the filtration, what I'm curious to see is how high the connectivity is in the system. The system, typically city water is 85 microsiemens, and when you add chemical to it in a closed loop, to get the right ranges for nitrite, you would be between 400 and 600 ppm, which would basically push the connectivity up to about anywhere from 1400 to about 2500, typically in New York City water. Now, that tells me that I know that the system's treated. Molybdate, usually as long as there's not too much caustic in the product, you can wind up having probably around 1300 to about 1700 on the conductivity, and it would be treated within range of 100 to 200 on sodium molybdate or molybdate for your inhibitor. Those are pretty much the two inhibitors that are mostly used in New York City for closed loop systems. So what I'm going to do is I'm going to take a sample of the water, the dirty water, and I'm going to put it into the conductivity meter. And I am going to push read. The connectivity is about 105. City water is 85. You can see the meter. That tells me that there is no chemical in the system. Being that the system is actually fairly tight, and there's no pump packings leaking, I did an inspection while I was in the building, it would lead me to believe that the system's being undertreated. Therefore, not addressing any of the corrosion issues. This is a side-by-side comparison of a new filter and a filter that we just used to basically see if the particulate that was in solution could be removed through filtration, and you could take a look at that. It does a great job of removing it. So filtration is definitely something that should be considered at this building location.